Hello everyone, so I'm just going to go through the paper which we did on Thursday's lesson. So when we come into a mechanics test, so without even reading the question, I want you to write down the 5 formulas we learned in mechanics using SWOT. So the first one is V equals AT plus U. The second one is S equals U plus V half multiplied by T. So if you can't remember the other 3, you must remember those 2 because you can use those 2 formulas to help you to figure out the other 3. So the third formula is V squared equals 2AS plus U squared. So you're going to use this formula when we have no value for T. Number 4 is S equals UT plus half AT squared. We're going to use this when we have no value for V. And the last one is S equals VT minus half AT squared. So we're going to use this formula when we have no value for U, the initial velocity. So we're definitely going to use those 5 formulas in the test. So it's really important you memorize those 5 formulas by heart and know when to use each one of them. So let's look at question 1 together. So with mechanics, it's about reading the question and understanding it. So the velocity time graph. So here is a velocity time graph. And we have a train P traveling along a straight horizontal track between 2 stations. They are 1.5 kilometers apart. So what we learned from before, remember the areas underneath a velocity time graph is the distance traveled, because velocity is meters per second multiplied by t, which is second, is going to give us in meters. So the area underneath the whole graph is going to be 1.5 kilometers, which is going to equals to 1,500 meters. The train P leaves the first station, accelerating uniformly from rest for 300 meters. So it's from rest, from 0, accelerating to 30. We don't know what the time is, but we know the distance traveled is 300. So we know this part here is 300 meters. So this triangle here underneath the graph is 300 meters. Until it reaches a speed of 30 meters per second, the train then maintains the speed for t seconds. So when we reach 30 meters per second, the train continues at the same velocity for t seconds. Then we taught the train before decelerating uniformly at 1.25 meters per second, come a rest at the next station. Then it decelerates. So the gradient of here is 1.25 minus 1.25 because it's deaccelerating. So let's look at question A. So part A wants us to find the acceleration of P during the first 300 meters. So let's look at our SWOT. So when I'm answering this type of question, I always write out my SWOT. So SUVAT. Then considering what information, so I know the displacement is 300 meters, which is taught. So the initial velocity is 0 because I'm traveling from 0 velocity. What's my final velocity? It's 30 because I'm stopping So it did say in the question, accelerating to from rest to 300 meters until it reached the speed of 30. So I know my final velocity is 30. Then my acceleration, this is what we want to find out. And time is not given. So look back to our 5 original formulas. So, it's here. So when we have no value for t, we're going to use equation 3. So we have v squared equals 2as plus u squared. So we're just substituting our numbers. So v is 30 squared. 2 multiplied by a, which is, we don't know. We want to find out, and s is 300 plus u squared. U is 0 squared. Then we just solve our equation to find out acceleration. So we have 30 squared is 900 equals 2 times 300 is 600a plus 0 squared. Then we just solve our equation. So a would equals to 900 divided by 600, and we'll simplify this to 1.5. So a is equals to 1.5 meters per second. Now look at part B. Find the value for t. So we want to find this distance here for t. What other information do we know? So let's look at the question. We know that total distance is 1,500 meters. So we know the area underneath this is going to be, so this whole area has a total of 1,500 meters. So what we could do, we could find out the time for each. So we could split the shape into 3. So this is our shape number 1, number 2, and number 3, and they're going to add up. The area underneath has a total of 1,500 meters. So let's look at the first part. So we know this is 300, but we don't know what's the time going to reach here. So we can find out the time, how long it would take for the time to reach from 0 to 30 meters per second. So looking at our equation, we can use the first one, v equals at plus u. So again, so we know that v equals u plus at, which is our equation number 1. So we know the final velocity is 30, our initial velocity is 0, and we plus a, which is, we just found out, 1.5. So we can find out the time for t. So just rearrange our equation. So we found t going to equals to 20 seconds. So just come back to label our diagram. So we have 20 seconds here. So we know at this place here, it would be 20 plus t at this time here. And now we want to find out the time here. So the time here would be 20, then plus t, then plus some other value. So we're considering part 3. So how long would it take for me to get from this point to this point? So what's going to be this value here? So again, I'm considering my SWAT for the deceleration. So remember, let's do my SWAT again. So SUVAT. So I don't know what my s is, but I know my initial velocity is this point here, which is 30. And I know my final velocity is here, so I'm stopping, so it's going to be 0. And I'm told in the question, it deaccelerates uniformly at 1.25. So in mechanics, so when it's deaccelerating, it's negative 1.25. And I want to find out my t. Again, we can just use our first equation, v equals at plus u. So v equals u plus at to find out our time. So v is 0, u is 30, we have a is minus 1.25 t. So we can rearrange our equation to find out t. So t is going to be equals to 24 seconds. So we know at here is 20 plus t plus 24. So we know the times taken. So now, what kind of shape do we have? We have a trapezium. And to find out the trapezium, so remember, the graph underneath is equals to 1,500 meters, and the area for trapezium is half times the height times the top plus the bottom. So our top is going to be t. Our bottom length is going to be 20 plus t plus 24, and our height is 30. So we can substitute our values. So half times the height, which is 30, times by a, which is the top, which is t. So the top of a trapezium is length t, and the bottom length is 20 plus t plus 24, which is plus 20 plus t plus 24. And we know the area is equals to 1,500 meters. So we're just going to solve our equation. So we have half times 30 multiplied by t plus t, which is 2t. 20 plus 24 is 44, which is equals to 1,500. So half times 30 is 15, multiplied by 2t plus 44, which is equals to 1,500. Then we can divide 15 on the other side, so we have 2t plus 44 equals to 100. Then just rearrange, so 2t equals 100, take away 44 is 56. Therefore, we have our t equals 28 seconds. So question 2, it asks us to sketch the speed time graph of the motion. So when we're doing a speed time graph, so we know it's going to be, so it's only a sketch, so they don't have to be to scale. So we know when it's a speed time, so we're going to have our axis, so speed on this side and time. So remember, speed, the unit is meters per second, and time is in seconds. So let's read the question. So a car is traveling along a straight horizontal road. The car takes 120 seconds to travel between two sets of traffic lights, which are 2,145 meters apart. The car stopped from rest at the first set of the traffic light and moved with a constant acceleration for 30 seconds until it reaches 22 meters per second. So it's saying the car stopped from rest. So when the car is at rest, so I'm just going to do this in a different color. So when the car is at rest, so it has a velocity of 0. And time, it will be also 0. Then it's from rest. Then it moves with constant acceleration for 30 seconds, and it reaches 22 meters per second. So it's accelerating at constant. So we know at here it's going to be reaching 22 meters per second, so 22. And we know the time here is 30 seconds. Then the car maintains this speed for t seconds. So it's maintaining this speed for t seconds. So at here, so this distance is t. So when it arrives here, it'll be 30 plus t. Then the car moves with constant deceleration, coming to a rest at the second set of traffic lights. So remember, back to the start, the car takes 120 seconds to travel between two sets of traffic lights. So we know it deaccelerates to 0. And we know at here it's going to be 120 because the car travels to 120 between the two traffic lights. And it says when it's come to the second set of traffic lights, it comes to rest, and therefore the velocity would become 0. When the speed would be 0 when it's at rest, and it's at 120 seconds. Part B asks us to find the value for t. So again, we have a trapezium. So to work out the trapezium, we have, again, similar to the previous question. So we have half times by height. Then you got to multiply by top plus bottom. So this is your formula for finding the area of a trapezium, and we know it's going to equal the distance 2,145. So let's do this. So we want to find out the value for t. So we know the height is going to be 22. So half times 22 multiply the top, which is t, plus the bottom, which is 120. And it's going to equal 2,145. So we're just going to solve our equation. So we have 11 multiplied by t plus 120 is equals to 2,145. So we know t plus 120 is equals to 2,145 divided by 11, which is 195. Therefore, we know t is equals to 75.